So thank you for inviting me and letting me talk about this new large project that we have in Norway, which is called LINKS, which is linking what we hope large-scale, cost-effective, permanent offshore storage across the value chain. And what it actually is, it's a Norwegian Green Platform project, so that's the Norwegian variant of the EU Green Deal. So it's industry-driven, and it is with some, thank you, SINTEF as a research partner, but otherwise there are only industry partners. So what we would like and hope to do in this project is to drive the green transition at the Norwegian continental shelf, and to see how we can use the existing infrastructure and reservoirs in order to upscale and to do large-scale CO2 storage. So, and the project is divided into 4 technical sub-projects. I hope you can see, the different work packages. So the first work package is for compact CO2 capture on site at the facilities in order to make the injection emission-free, so that all the energy required on site is emission-free by capturing the CO2, and then you store the CO2 immediately on the platform. Then the next part is the transport, where we would like to look into the possibility to capture and store for the energy sources for driving the vehicles itself, or the ships. So that also reducing the emissions for the transporting of the CO2 that's necessary. And then we have the third sub-project, which is to look into all the existing infrastructure that we have in the North Sea, and to see how that can be reused in order to store CO2, but also perhaps into new storage aspects like hydrogen, seasonal hydrogen, and also ammonia. And then you have the last sub-project, which is the integrated chain, also integrating all the aspects of the 3 earlier work package into a value chain. So, and this is a project that started last year and will last for until 2024. But even though it's just a 4-year project, it has quite ambitious target, I will say, because it claims that it hopes to create more than 1,000 jobs at the Norwegian continental shelf based on the CO2 storage, and it also is going to store more than 100 megaton CO2 per year into the North Sea. So we're hoping that we could create a CCS ecosystem in the North Sea based on this. Okay, so the partners, as I said, there were, in addition to SINTEF, there are just industry, and Aker Solutions is the one that's heading the project. Aker Solutions, I don't know, these are, of course, since it's a Norwegian project, it's mainly the Norwegian companies involved, but Aker Solutions is the company that is responsible for the intermediate storage facilities of the Northern Light project, so they are already very much involved in the business. And as you can see also, there are operators like Equinor, Aker BP, Total Energy and Wintershall, and Vår Energy and AGR. So there are quite a lot of operators interested, and then we do have also companies with data treatment and digitalization, which is part of this. And all this is funded by 3 different governmental institutions or enterprises. So it's the Research Council of Norway, and we have 2 other bodies in Norway. It's the Innovation Norway and SIVA, which are enterprises that are going to facilitate and support new innovations in Norway. Okay, so since we here are related to the storage part, I would like to go more into the work package, the sub-project 3, which is looking at the capacity of expanding the capacity that we have in the North Sea. Okay, so the main objective of this sub-project is to, what I mentioned, a reuse reservoirs, so that means to look at depleted reservoirs, and also infrastructure, so we could use that for CO2 injection and storage. And also, as mentioned, then perhaps when this is done, we could also use it for seasonal storage of hydrogen and ammonia. So the sub-project is, again, like all projects we have, is put into different tasks. So first of all, we are looking and establishing a reuse atlas. So it can be used both for communication, but also for authorities and for operators to see the possibilities that are. And it is including depleted reservoirs, wells, pipelines, and also topside equipment. To some extent, it would, in Norway, we have the open page of the Norwegian authorities for fact sheets for all fields and also related to all wells that are in Norway, so that's quite established. But the challenge is, especially because with the development of the oil and gas industry, it's like a lot of the fields that are still producing in the North Sea, we believed were not supposed to produce 10 years ago because it's new technology, so we continue. So facilities that we might believe now will be available for CO2 in 5 years' time will not necessarily be that because of the development in the oil and gas industry. So that will be a difficulty or challenge when you're setting together an atlas like this, because if you're including the time scale that you really need to see how you can reuse it. So this is also something that's good when you do have the operators, at least for the fields that where the operators are partner in this project, we will be able to have details related like that. And then when we have, and at SINTEF, we already have started to look at the well integrity atlas. So it's looking into and to see exactly what's the status of the well. We do have a kind of complex mixing of producing wells, partly abandoned wells, and then completely abandoned wells. And the condition for those needs to be put together and to systemize. So this example here, the figure is from the Troll field in Norway, where we have made a prototype just to see for the atlas and see how it can be used. So the work here will be sort of based on this prototype and expanded. And then on top of that, it will be made a decision tool in order to see how to fit all these different components together and to see actually if it's possible to reuse the different part. Okay, so then we are looking into different type of injection volumes and the possibilities. So this for the small scale injectivity studies, we are more or less looking at like the CO2 that we will capture on site. How can we store that the best? Because you have two different options. You can either have your CO2 to be immersed in water, so you have carbonated water and you can inject that, or you can just have CO2. But the problem when you do this, because then it could be to see if it's going to, how the CO2 is really moving into the reservoir. So we're coming a bit back to that, because especially carbonated water, then you have different challenges with respect to resolution than when you just have pure CO2. But that comes to an aspect of monitoring that I will come back to a bit later. And also the same, when you look at the medium scale injectivity, then it's also like we had a case study that we were going to use, that was the Brage field. But so it was Wintershall's field, but they sold it, so we are looking for a candidate for doing the field study. But the point here was that you actually, while producing oil and gas, you also wanted to inject CO2 in carbonated water to use that as a pressure buildup, to see the feasibility of actually using that CO2 that's captured also directly into storage while you use produce oil and gas. So it's not a EOR, but it's more for pressure pressurizing the reservoir for increasing the production of oil, but then if you also emerge the CO2, then you get rid of that when you do capture it on the site. And then all along with this, it's not that easy that when you do start to inject, to model when you do your injection into depleted reservoirs, because then you do have some oil or gas in your reservoir already, and then you inject CO2, so you have water. And how to handle that, and the industry is more and more looking forward to having open source codes in order to do these kinds of simulations. So this is what we are looking for, and to develop a tool that can be used for depleted reservoir where there is leftover oil and gas. Okay, and then to the monitoring part that I mentioned. So for the monitoring part, it is very important for different aspects when it comes to the well, because one thing is the condition that the wells are, because as you probably know that the Norwegian continental shelf is just, you have hundreds of wells that are all over, and they might be leakage points for a CO2 storage. So to know the conditions of all the wells, and specifically for the wells that are in your area where you would like to store, you need to know more about. And with respect to that, we have started working on looking at geophysical methods. That means either sound or electromagnetic fields, in order for remote looking at the well structure, and to see how this can give us information about the integrity of the well. And also if, for instance, the cement starts to degrade because of the presence of the CO2, if this type of monitoring, which is normally used for exploration, can also be used and adapted to the wells themselves. Another aspect for the well is that the well might leak, and so that you can see that CO2 is leaking around the well. And with that respect, and also to control the injection, it's often that now they install fibers in the wells in order to monitor this. So I just brought two different fibers, so you can see. It's not that easy to see the fibers itself, but this green one is measuring, they look the same, but the red is for temperature, and the green one is for acoustics, thus. And there are 4 fibers in each cable, and these ones are the typical what you can have and install in your injection well. And it's already been proven or investigated that the dust can sort of hear the bubbles of the CO2 if it leaks on the outside. So if you'd like to take a look. See the fibers, they are almost invisible because they are transparent. And that is what we're going to do at the Svelvik CO2 Field Lab, where unfortunately when we established this site in 2019, we used an old existing well, and when we did the first injection, we realized that the well was leaking. So turning that into a positive thing is now we are going to install fiber and to see the possibilities of actually detecting the leakage that we have observed. So that was related to the monitoring of wells, which is quite a new area and interesting. That's especially important when you go into depleted reservoirs where you have a lot of wells, production wells from before. In addition, also, it's very important to look for, as I mentioned, the monitoring in general of the CO2 plume, where it goes and how the pressure builds up. It's a bit different when you have in depleted reservoirs, but it's also important to minimize the cost. So it's sort of looking at how sparse measurements can be replacing the more dense monitoring schemes that are normally now used. So let's say, and these two aspects for the monitoring is also done in close cooperation with an EU project, Act 3 project called Return, that I will talk about later tomorrow, since Pierre is not here. So, okay, so I guess that is more or less what I have. They have a webpage that you can go into and see more detail for all the sub-projects that the projects exist of, but in general. So there are not many results yet because we are quite early into it. But I hope that we quite soon will have some good results to present for you. Okay? So thank you.